Awesome. Hey, everyone. Hope you're having a lot of fun in person. Definitely unfortunate that myself and the Forest team couldn't be there, but for you next week at DevCon. Today, I'm going to give a bit of a high-level talk on how blockchain nodes provide access to on-chain data. At ChainSafe, we're building Forest, which is a Rust implementation of the Filecoin protocol. And we're kind of in an interesting position at this point where we can perhaps look at some novel approaches to exposing some of the chain data and try to adapt to some of the pressing use cases. And so that's really what brings me to this topic. I'm going to start by just covering some basics here. I mean, the diagram in the top right there should be fairly familiar to most of you. This is kind of the naive perspective of a blockchain. We have a set of blocks, each containing transactions that are cryptographically chained together. In reality, like the full story is maybe a little bit more complex, which is the diagram at the bottom. We have a set of transactions in a mempool on the left, and on the right, we have a database of some sort containing two types of state. One is the storage state, which is ultimately the data that the transactions actually operate on. So, for example, an account balance or a smart contract might be stored there. And then there's also the chain state, which is where the actual blocks and transactions are stored. And in the process of creating a new block, really what's happening is that the current state and a set of transactions are passed into a state transition function. This mutates the storage state by executing those transactions, and the resulting block from that is then stored into the chain state. And so really this is just to illustrate that, the blockchain represents the modifications to the state, but not necessarily the state itself. And so kind of the intermediary states between blocks is not inherently represented. The most recent state is most likely preserved, but past states may not be. I think this generally makes sense, right? Blockchains are designed to sort of fundamentally guarantee the integrity of data. They don't necessarily make any guarantees about lookup times or the availability of those past states. And so, for example, if I wanted to find all transfers to my account, you'd actually need to go back through all of the blocks and effectively replay each relevant transaction to get a complete picture of what has occurred. Obviously, this is very expensive and slow, and sort of as theory moves into practice with blockchain node implementations, this is a challenge that needs to be addressed. And so some of the basic ways that this is managed is by simply storing those previous states so that they can be quickly retrieved and looked up. But even with the previous states, not all data may be immediately available. So you may also need some caches to avoid recomputing certain elements and keep them available from some of the more recent states. Adding additional persistent data stores is also very helpful here. You can use more traditional databases and store a more complete set of state. You can also optimize queries through common techniques like database indexing, and so this can definitely improve the performance of lookups quite significantly. And in some cases, we just don't worry about this, right? Some users may only need more recent pieces of data that are available, or we kind of offload this to other systems and utilize other solutions outside of the node itself. In Filecoin land, this is a particularly notable problem due to Filecoin's huge state compared to other chains. And so there's the notion of a full archival node, which is basically a node that stores all previous states. And for Ethereum, a full archival node on mainnet is about 12 terabytes of storage. whereas Filecoin mainnet it's about 50. And I mean, keep in mind that the Filecoin chain is much younger, and yeah, it's definitely growing at a much faster rate. It's fairly difficult to run a full archival node on Filecoin. It's just a huge amount of data, and it can be very difficult to actually bootstrap. And in many cases, it's really just the FEVM data that users are particularly interested in, which is really only a small portion of all of this data. And so how do nodes on Filecoin network actually deal with this? Certainly utilizing additional data stores is a fairly effective method. You provide much more efficient read access to state, but it obviously comes at the cost of additional storage space. This can also introduce a lot of complexity while not really improving the fundamental ability of the node to actually follow the chain and potentially participate in consensus. Most nodes also support our good friend, the garbage collector. And so they're configured to basically store some number of previous states. And so the garbage collector will routinely run and prune out those older states to reduce the amount of disk space that's actually required to maintain the node. And of course, this means that those nodes can only provide some amount of past state, and ultimately would need to request anything beyond that from the network. And certainly today there's less than ideal amount of nodes on the network that can provide some of that data. And so income indexers, these are a fairly simple concept. They're sort of a general solution for improving the retrievability of the state. Typically, they'll depend on a node to initially fetch the data. It'll be fed through some preprocessor, which may make additional requests to the node to get some of the subcomponents of the data. For example, if you have a block, you might then need to go and get all of the transactions within that block. It may also need to monitor for things like forks in the network, wait for finality, or make any other considerations depending on the protocol. The data is then stored in usually some sort of classic database, and then made available through an API for users to query. These APIs are usually much more ergonomic than what a blockchain node would normally expose, and they can be easily adapted to particular use cases and just improve that usability even further. Indexers are typically implemented in a somewhat centralized fashion, and may not provide the same guarantees of data integrity that a node would. But I would say it's generally considered the benefit of the UX outweighs this potential cost. So now just touch on some of the existing solutions. So the graph is probably the most widely known. They've been around for many years now, and started in the Ethereum space. They have really accelerated Web3 from my perspective, as they've provided a lot of the sort of fundamental components to actually make many of the dApps that exist today possible. They've also contributed a lot of sort of infrastructure pieces that can be reutilized and just make managing the data that much better. Subsquid is a bit more recent. They were actually born from the Polkadot ecosystem. They saw a lot of success in indexing substrate chains in particular. Substrate also has an EVM, and so they kind of opened the pathway to also supporting other EVM-based ecosystems. It's interesting to see both of these kind of move towards decentralizing their systems. They're attempting to enable just about anybody to perform the necessary computation to index data and to store it. And are ultimately leveraging financial incentives to ensure the correctness and reliability of these participants. Fundamentally, these systems function very similar to the diagram that I just showed. although they certainly do have a lot more complexity with various optimizations and UX features and tooling and whatnot. So bringing this back to Forest, as I mentioned, Forest's implementation of the Filecoin protocol, we place a significant emphasis on performance, ensuring that Forest has a minimal resource footprint. We're also focused on providing a great user experience, which ideally in turn reduces the required amount of maintenance work and can further reduce the cost to operate. We are very interested in improving the experience of two particular user groups, one being RPC providers and the other one being indexer service operators. And certainly the strengths of Forest make this a great match. More recently, we've been exploring something called Firehose, which is a file-based streaming approach to extract data from blockchains. This was built by some of the teams behind the Graph. It's a fairly chain agnostic solution and can be consumed by many different applications, not necessarily just the Graph. Its focus is on pulling the data out of the node and making it available for something like an indexer service to then actually consume and provide to users. When it comes to getting the data out of the blockchain node, the JSON RPC interface is kind of the simplest and perhaps the most naive solution. JSON RPC is really a bit of a legacy technology choice in the blockchain space. Certainly for myself and the Forest team, we firmly believe that there are better alternatives. And certainly have run up against many of the pain points of trying to use something like JSON RPC for dealing with blockchain data. Firehose is interesting in that it kind of promotes the idea of instrumented blockchain nodes, which are customized in a way to make the extraction of the data easier, particularly by enabling streaming of data rather than polling, which is often required when interacting with the JSON RPC interface. To kind of build a custom implementation of Firehose, you start with the protobuf definition of the data. You then instrument the node to expose that, typically through files. And then there's tooling to basically consume that and process it. You can see there's a few different components here, like the relayers, which are used to kind of stream live data out of the node and make it available. Or alternatively, you can go through the merger component, which provides a similar role, but more so for historical data. And then all of this is exposed through the Firehose with an interface such as gRPC or GraphQL or anything else that you can really dream up. Some other improvements in this space that we're looking at, we really want to deliver features that enable better querying of data, either directly from the node or indirectly via solutions like indexers. And so we are continuing to explore and experiment with Firehose and Subsquid as well. The reality is that the JSON RPC interface isn't going to go anywhere, certainly not anytime soon. And so we are continuing to expand and improve our implementation, specifically focusing on the performance of that. Of course, we are going to explore alternatives in parallel, but we also want to be mindful not to bloat the node software with features that should perhaps be pushed out to things like indexers. We're also very interested in the potential for F3 light clients. With a light client, you can reduce the reliance on centralized RPC providers, can also complement an indexer very nicely because you can actually validate some of the data before acting upon it. And given that Forest is written in Rust, it's a great candidate for a WASM-based in-browser-like client, or at least reusing some of the components. We're currently starting an implementation of F3 in Rust, which would certainly be an important dependency for this. So that's all. yeah, hopefully it gives you a bit of a sense of the landscape and how we're looking at this. Certainly, if there is anybody here who runs RPC nodes or is doing indexing of data on Filecoin, we would love to talk to you, get your inputs, get your feedback. So please do get in touch with us. As I mentioned, we will be at DevCon, myself and the Forest team next week. So if anybody's there, please do come find us. But yeah, otherwise, thank you very much, and
Thank you.
enjoy the rest of FDS.